Using the diagram, calculate the size of angle X. And so here we have angle X, and angle X is one of the three angles in this triangle. Now, what do we know about this triangle? Well, notice that we have these two strokes or these two lines on this side of the triangle, and we also have it on this side of the triangle. What does that mean? Well, that means that these two sides are equal. They are equal in measure. And so that means that we're dealing with an isosceles triangle because the two sides of the triangle are equal. Since we're dealing with an isosceles triangle, since the two sides of the triangle are equal, that means that not only the two sides are equal, but that means that the two angles are equal as well. So that means that since we have on this side, since this is X, this must also be X as well. And so we have 54 degrees, X, and these are the angles inside this triangle. But our goal is to figure what is the size of angle X. What we do know is that if we add up all of the interior angles in a triangle, we should get 180 degrees. So what we're gonna do is we're gonna take 180 and we're gonna subtract that with 54, right? So we take 180 and subtract that with 54. Then we're gonna divide it by 2. And the reason why we divide it by 2 is because we need to split that result and share it among these two angles. And so we have 180 degrees minus 54, and we have to divide that by 2. So 180 minus 54 is 126. And if we divide it by 2, we get 63. And so that means that X is equal to 63 degrees. This is 63 degrees, all right? And this is 63 degrees as well. And it makes sense because 63 plus 54, if we add these three angles, we get 180 degrees. Next, our goal is to determine the size of angle Y. So this is angle Y right here. Now, angle Y is one of the three angles inside of this triangle, all right? So Y, we have 72, and we have this angle right here. Now, notice that this side of this triangle has two strokes, and this side of this triangle also has two strokes, which means that this side and this side are equal in measure, they're equal in length. So that means that we're dealing with an isosceles triangle. And for an isosceles triangle, not only are the two sides equal, but the two angles are equal as well. So if this is 72 degrees, this must also be 72 degrees as well, all right? 72 degrees. And so what we have here is we have 72 and Y. What we do know is that angles in a triangle must add up to 180 degrees. And so in order to figure out the size of Y, we're going to take 72 and add them. And then we're going to take that sum and subtract it from 180 degrees. And so we have that Y is equal to 180 degrees minus 72 plus 72. And so we have 180 degrees minus 144 because 72 plus 72 is 144. So we have 180 minus 144. That's because 72 plus 72 is 144. So we have 180 minus 144, and we subtract the 2, and we get 36. So that means that Y is equal to 36 degrees. Next, we need to figure out the size of angle Z. We need to figure out the size of angle Z. Now, angle Z is right here. And if you notice, right, we have X, we have 72, and we have Z. Now, all three of these angles are on this straight line at this common point, all right? And they must add up to 180 degrees. So that means that angle X, 72, and Z, if we add them up, they must add up to 180 degrees. And so what we're gonna do is we're gonna take 63 and 72, we're gonna add them together, then we're gonna subtract that, and then we're gonna take that sum of the sum of 63 and 72, we're gonna take that sum and subtract it from 180 degrees because angles on a straight line at a common point must add up to 180 degrees. So we have 180 minus 63 plus 72. 63 plus 72 is 135. So we have 180 minus 135, which gives us 45 degrees. And so that means that the size of angle Z is 45 degrees. And that's our answer to this question.